Hello students, let us see some questions from grade 9 science.
Question number 1. Assertion and reason question. Assertion is connective tissue connect and support different parts of the body. Reason blood is a type of connective tissue. Answer is option B. Because assertion is true, connective tissues include bone, cartilage, ligament, tendons, adipose tissue and blood. Their main function is support, connection and transport in case of blood. Reason is also true. Even though blood is a fluid, it is considered a connective tissue because it connects body system by transporting nutrients, gases and waste. Relationship. The reason explains why blood is considered a connective tissue, but it does not directly explain and the assertion. Question number 2. Differentiate between striated and smooth muscles. Answer. Striated muscles like skeletal and cardiac muscles, they have visible stripes or striations under a microscope. In smooth muscles lack striations and appear uniform or smooth. Second point, striated muscles multinucleated and long cylindrical shape. Smooth muscles are uninucleated and spindle shaped. Question number 3. Draw and explain the structure and function of nervous tissue. Answer. You should draw the neat diagram of nervous tissue and labels. Function is transmission of signals. It carries messengers between the brain, spinal cord and rest of the body.
Question number 4. Which of the following figures does not represent Bohr's model of an atom correctly? Option A and B. Option B, B and C. Option C, B and D. Option D, A and D. The correct answer is option C, B and D. Figures B and D do not represent Bohr's model as they depict electrons embedded inside the atom like Thomson's model instead of revolving in fixed orbits. Bohr's model illustrates electrons moving in definite circular paths around the nucleus. Question number 5. Can all rays are made up of A. Positively charged particles, B. Negatively charged particles, C. Neutral particles, D. None of these? Answer. Option A. Positively charged particles. Question number 6. Rutherford concluded that the nucleus is very small compared to the size of the atom. Justify this with the alpha particle scattering experiment. Answer. Very few alpha particles deflected back, indicating that the nucleus must be very small. Most of the alpha particles passed straight through the atom, indicating that the atom is mostly empty space. Hence, the nucleus is dense but occupies only a tiny fraction of the atom's total volume. Question number 7. Distinguish the properties of electrons, protons and neutrons. Answer. Electron. It is present outside the nucleus of an atom. Carry negative charge. Its weight is negligible. Proton. It is present inside the nucleus of an atom. Carry positive charge. It weighs around 2000 times the mass of electrons. Neutron. It is present inside the nucleus of an atom, which is neutral. Weight is the same as a proton. You have to write any 2 points for each particle.
Question number 8. The weight of a body would not be 0. A. At the center of the earth. B. During a free fall. C. In interplanetary space. D. On a frictionless surface. And the answer is option D, on a frictionless surface. This is because in all other cases that is listed in the options, it is going to be 0. Question number 9. Assertion. We cannot move even a finger without disturbing all the stars. Reason. Every body in this universe attracts every other body with a force which is inversely proportional to the square of the distance between them. And the answer is option A. Both A and R are true and R is the correct explanation of A. This is because all objects in the universe obey the universal law of gravitation, and thus the reason explains the assertion well. Question number 10. A force of 20 Newton acts upon a body whose weight is 9.8 Newton. What is the mass of the body and how much is its acceleration? Take g to be 9.8 meter per second squared. And the answer is, here W is equal to 9.8 Newton and g is equal to 9.8 meter per second squared. Now mass of the body can be calculated using the formula W by g. So this will be 98 by 9.8, which gives 1 kilogram. Given that the force is equal to 20 Newton, and from previous result we have mass to be 1 kg. Therefore, from Newton's second law of motion we have F is equal to ma. So acceleration will be A is equal to F by m, which is equal to 20 by 1, that is 20 meter per second squared. Moving on to question number 11, part A. Derive an expression for acceleration due to gravity on a planet of mass capital M and radius capital R. Part B. Gravitational force acts on all objects in proportion to their masses. Why then a heavy object does not fall faster than a lighter object? And the answer goes like this. Let us consider the gravitational force F between an object mass small m on the surface of the planet of mass capital M, both separated by a distance of capital R. Now, according to the universal law of gravitation, we have the force of gravitation to be capital F is equal to gmm by r squared. From second law of Newton, for objects under the influence of gravity, we have F is equal to mg. Equating 1 and 2, we have gmm by r squared is equal to mg. Cancelling common terms, we have gm by r squared is equal to small g. B part, a heavy object does not fall faster than a light object because the acceleration due to gravity is the same for all objects regardless of their masses. All objects fall at the same rate under gravity alone. Thank you.